Hi, Mr. X with glossary term infinite. Informally, in common everyday language, we say something is infinite if it's uncountable. Like the number of waves in the ocean. We could never count them all. So that we'd say the number of waves on the oceans, on all the seven seas, throughout time. How many ocean waves have there been? Well, there have been an infinite number. Well, that's how we approach it in everyday language. In math, actually, that would be finite. There would be a way to actually count those if we were clever enough to do it. We'd say, well, the number of grains of sand in all the Sahara Desert would be infinite. Well, that's only in informal language. In the language of math, the number of grains of sand in the Sahara Desert would be finite. They'd be countable. It'd take a while. No one person could do it in a lifetime, but there's a finite number of grains of sand in the Sahara Desert. Really? All the grains of sand? Not infinite? No, it'd be finite. So what is infinity, and what does it mean to be infinite? How about the number of stars in the night sky? Would that be infinite? No, actually, that would be finite. Big number. How about the number of molecules of water in the ocean? Surely that must be infinite. No, even all the water molecules in all the oceans and all the aquifers and all the clouds be a really, really big number. But mathematically, that's still not infinite. Still not infinite. It'd be a very large finite number. Now, in human terms, it's infinite. Like the number of thoughts that have ever been thought, or the number of snowflakes that have ever fallen. In human terms, those are infinite. But in math? No, those are finite. So what does infinite mean, without bound or limit? Well, try this. All right, here's a piece of a number line. This is 10. This is 20. This is 15. So far, so good. We could zero in on the number line, though. We could get closer and closer to this 15. Why don't we do that? We could make that 14 and make that 16. We could be really zeroed in on it. How about that? What if we were really, really, really zeroed in on it? I mean, if we really, really zeroed in on it with a magnifying glass, a really good magnifying glass, couldn't we have this part of our number line? In fact, if we had a microscope on this number line, do you see where this is going? Between any 2 points on a number line, between there and there, how many points are there? There are an infinite number of points between any 2 points on a number line. Seriously. Between any 2 points anywhere, there are an infinite number of points. Because mathematically, a point has no size. It's merely an idea. No matter how many decimal places this 14.999, no matter how close we get to 15, we can get closer and closer and closer to 15 without touching it. All we need are more decimal places. We can get closer and closer to 15 from this side. All we need are more zeros. And we'll get closer and closer and closer to this 15. We can get as close as we want without touching it. All we need are more decimal places. And what's the limit for decimal places? Well, there's no limit. We can just keep adding decimal places. Now that's infinite. Mr. X takes the mystery out of math at mrxmath.com.